Anant Kulkarni.
Thank you, Dr. Padma Vankar. I welcome you all for this last session. It gives me great pleasure to introduce today's chair for this last session, Dr. Swapan Ray, who is mentoring newly formed sustainability team at Reliance. As you are aware, he is honorary secretary and member of executive committees, Indian Center for Plastics and Environment, and you have heard more about him in the earlier session. So let me invite Professor Swapan Ray to be the chair of this session. Also, I take opportunity to honor him with a shawl.
I already got one.
And you will get another one.
And the momentum as the tradition. So please.
Okay, fine.
So Dr. Vankar, please.
Yeah. So here is the shawl, which you can use again to my Boro Dada.
Thank you very much. Thank you.
And here is the memento.
Thank you.
Thank you, sir. Thank you, madam. And over to you, sir.
Thank you. Yeah.
Thank you.
Thank you. Good evening, and thank you for that kind intro. Appreciate. So it's a good thing to get promoted like this. From being a speaker, now I'm chairing a session. So thank you, ma'am, for this honor. I appreciate. And also for this shawl, which I got on top of what I already had. So we'll start off this session by requesting our first speaker, Dr. Virendra Gupta. I'll request him to come on the stage, please. Dr. Gupta is head of R&D Polymer and Senior Vice President at Reliance Industries Limited. He has 40 years of experience covering teaching, research, technology development, and management. His significant and high impact technology development include concept to commercialization of engineering thermoplastics and catalyst to produce polyolefins. Dr. Gupta is an inventor and a co-inventor of 200 patents and successfully commercialized 30 technologies in petrochemicals and polymers in India. He has 80 research publications in peer-reviewed journals and 90 invited and contributed presentations in international and national conferences. Dr. Gupta obtained his PhD from Banaras Hindu University. He also worked at Indian Petrochemicals Corporation Limited, where we were colleagues there, and we continue to be colleagues at Reliance Industries. So it's a great pleasure, Dr. Gupta. I'll not I have pretty long this thing, but considering the time that we have at our disposal, welcome you for this first, as the first speaker for this session. Over to you, Doctor.
Thanks, Swapan. And I think Dr. Shivram is not here, but anyway, I wish a belated happy birthday to Dr. Shivram. And I think for me, giving a lecture on his 75th birthday celebration is important. The reason being that when I was in US and I was in touch with him, Dr. Shivram was the person who asked me to return back to India and giving me the opportunity to serve in IPCL and even offering a position without attending the interview. Because in public sector, before that, you need to attend an interview to get a position. So really, I'm very, very thankful to Dr. Shivram for giving that kind of opportunity to come back to India. Second thing is I was an organometallic chemist and in US working on semiconductors, gallium arsenides kind of materials. But when I returned back to India and Dr. Shivram was in IPCL, he introduced me to polyolefins, which was totally different than the semiconductor-based material. And I think that is a journey. Sometime in '88, I started in India to learn the polyolefin science and also some of the engineering aspect. So today, when his 75th birthday is being celebrated, and Professor Pillai told me that I should give a talk, then I said the best talk will be the area which I started after coming back to India with my first publication in this area with Dr. Shivram, to share with all of you how from '88 till today, the learning, the idea which he has given to me at that time, how I could take it forward, and today in India is able to convert that science into the technology. It is a long journey, lot of up and down, but finally, what Shivram was trying at that period of time in IPCL as a mission program in public sector to develop the polyolefin technology, although in IPCL it could not be achieved. And this is also example many times, many dreams, scientific dreams, you don't achieve in one organization. But if you learn the fundamentals, you don't know when the opportunity will come and you can use that to convert that knowledge in another organization. So for a scientist, and I think scientists are secular, so it doesn't matter which company they work, which industry they work, which university they work, the final goal is how the science can be understood and how it can be translated into a technology or the product which is useful to the society. And that's why I dedicate my today presentation to Dr. Shivram and sharing with you my journey in the area, which sometimes started in '88, many times dropped the idea of pursuing, and that's why I left IPCL, joined GARDA, and tried to learn from Dr. Trivedi the engineering thermoplastics. Because one time I thought polyolefin has technology development in India has no future. Nobody is going to spend that much of money and that kind of chemistry which is very, very extremely difficult. So sometime in '95, I decided that better to leave the area in an industrial organization which doesn't have a future to commercialize. And that is where Dr. Trivedi picked me up in GARDA. And there I realized that better to do in India the engineering thermoplastics, which is much more easier. And GARDA and Dr. Trivedi was very fascinated to pursue that. And I think few years we worked together in engineering thermoplastics, and I think ether sulfone, polysulfone. So 3 years my working with Dr. Trivedi has really taught me the engineering thermoplastic, and I think we could commercialize polysulfone during my period in GARDA Chemicals. But then opportunity came, and one day Dr. Shivram called me and said, Viren, now Reliance Industry is interested to pursue what you have come back to India. And then I told Dr. Trivedi that I want to go to Reliance Industries and pursue what I have learned in IPCL. And if they are interested to spend 100 crores or 200 crores, then let me pursue that dream. And Dr. Trivedi only asked me to stay for 3 months and then will leave me. And he relieved me in 3 months from Garda Chemical, although at that time we were in a much more difficult situation of commercializing polysulfone. And that is where my journey again restarted in Reliance Industries in '99. So even the second part of my journey in polyolefin started with Shivram because he pursued me to join the Reliance over there. And then the real success came, and which today I want to share with all of you. This is just a legal requirement before I speak in any place, because still I am a Reliance employee, that whatever I say is my personal views, has nothing to do with the Reliance Industries. And the reason I said that, why Dr. Shivram asked me to join in '99 when I was serving in Garda Chemical and enjoying the, engineering thermoplastics. And I think one of the reasons is that Reliance is a big organization, well moving in oil to chemicals and very strong financially, and really looking for build different technology. So therefore, not only the financial power, the other technological power was also there to drive the indigenous technology development. Next. And the second thing is that Reliance is very strong in manufacturing and business of polymers, commodity polymers, polypropylene and polyethylene. And in addition to that, the PVC and other. Therefore, it is of very, very important interest to the company also, because no company will invest the money unless and until they have a long-term interest. And at that time when I joined Reliance, I was not knowing, but when I met Kamal Nanavati, who was at that period of time in Reliance, he told that why he wants to hire me in Reliance. One of the reasons was that at that time the Pokhran time was there, and Reliance has a polypropylene plant at Hazira, and it catalyst contains titanium, and there was an embargo from US at the time of Pokhran time that no titanium metal can be shipped to India. And because of that, because these catalysts which are used for polypropylene production has a titanium, whatever the catalysts which were coming from US, because these catalysts were supplied from US, they were stopped. Then I realized no industry is looking for scientists, but when they are in crisis, they only look for scientists and the technology development. So this was the reason. So many times, a lot of people say industries funds easily, but I think there is a story behind that. And I think it is where we should also use this opportunity whenever such kind of crisis and other things are there, that within the time frame which they are expecting you to deliver, can you deliver at that period of time? So this whole story of last 20 years development, which I want to share in 15, 20 minutes, has come because of the Pokhran. And if we would have not developed those technology within 1 year period of time at that time, then it would have not been possible. So this is also very, very critical, that what Anubhav has told in terms of commercialization, but I think in commercialization of technology, time is very, very important factor. Something which is important in 1 year, if you delay for 2 years, it is out of the context. And that's why the Reliance is interested. Now, if you look at, I think in the morning, lot of importance has been given for polymer, already told, the versatility, the growth and challenges, and the kind of growth which is emerging. And I think Swapan has told, Professor Sharma has told that why such a growth is there. By 2050, we will have close to 1,300 million ton plastics over there, that in 100 years, 1950 to 2050, there will be 200 times growth in plastics. Now, with this growth, the challenges are also coming. Any growth always brings the challenges, and that's why, you know, a scientist and technologies are required. Otherwise, we will be the forgotten species, you know. And that's why I say the scientists and technologies will never be forgotten, because there will always be challenges which, if I am not in my period is not able to solve, the next generation is going to solve. So that's why science is a continuity. It will never be ended. But it will not be a full solution. Always there will be 70% solution, and that is the way the science keep moving. And I think what Sopanji has said, circular economy and sustainability, and I think this has become a very, very important part. So in polymers, particularly in polyolefins, which is close to 190 million ton worldwide, the circularity and recyclability, chemistry, science, and engineering will be the focus area of research in coming years. And I just mentioned as that today 190 million ton polyolefin production, and if you look by 2050, we expect double the amount of polyolefin material. And similarly, the circularity and sustainability will also be a critical part. And the kind of business potential which you look at, that in polyethylene by 2026, 143 billion US dollar, polypropylene business is close to also 122 billion US dollar. And I think these are driving not only the requirement and other, these are very business feasible, economically viable way to move in this area. Now, and I think it is very, very important if you look at globally, there are many players, Lyndall-Basel, Dow, today the Grace, and Chinese company also a major player. For India to enter into this area was extremely difficult to consider, because not only the science and engineering is extremely difficult to pursue this area, but these big players, technology player like Dow or Lyndall-Basel or Grace, they have thousands and 2,000 patents in this area. And today in this competitive world, if you want to develop your own indigenous technology, and particularly in a company like Reliance, this means you need to have something totally different idea to develop those materials in a different manner, not only the process side, but the composition side. And that's why that was my first challenge when I joined. How do I create a IP so that when we disturb these big players like Lyndall-Basel and Dow, then they should not come and have litigations and other issues, because these are the big players, and Reliance stakes are also very high. We created that fundamental understanding using the past experience. And if you look at today, Reliance, around 40% of the total capacity of India catered by Reliance in the polyethylene. In polypropylene, close to 50% of Indian requirement is catered by the Reliance. And now many players are emerging in this area the way the growth is emerging over here. Now, in order to create the technologies for polyolefins, one should know the total chain of understanding which need to be created. Whenever you develop any material technology, you need to see what are the key components, because material technology is not just one technology. It is a combinations of technology which allow you to create the material technology. In polyolefin, if you look at, there are 4 major parts today. First is the catalyst technology, and catalyst technology is a very proprietary, and most of the technology licensor, they keep it with them and highly patented over there. Second part is a product application and technology, because this is a customer centric, new application, new product you develop, you need to create that, and this is where the major money is, not the commodity materials. That when you develop the applications, whoever is the first mover make the most of the money, not the second mover or the third mover. The third is a polymerization technology, and the fourth today is a recycling technology. And that is what our ambition is, our dream is, that one day that Reliance will have all those technologies with them, so that they become also the world leader like the Dow or the Grace Davisons or the Lyndall-Bassel. And I'm sure the kind of development which has taken place in last 20 years in Reliance will one day will keep us unequal to these world leader, and maybe much more ahead from the world leader. But the journey has to be started from somewhere, because science and engineering is not a very fast. It goes a slow process, and it takes also the time to create a world-class technology which is a globally competitive. And the first focus was on a catalyst technology and the product and application technology, where we have focused first on that. Today, the Reliance is focusing also on a polymerization technology and recycling technology over there, so that these all 4 platforms for polyolefin technology can come, and there will be a time when Reliance can offer the polyolefin technology like Lyndall-Bassel offered the technology or Univation offered the technology. And I think this is also told why this development. I said today is a 200 million ton polyolefin, next 30 years double 400 million ton. The reason this double the growth in next 30 years will be because of the food security, health security, energy security, defense security, housing and infrastructure. Because today everybody is looking for security. You know, the kind of war which is taking place now, Ukraine and Russia, this means each nation should have their own security for any knowledge or technology development, because future war will be knowledge war, and anybody can stop or derail the economic development of a country by stopping any of those knowledge chain over there. And that's why it is very, very important that we should speed up this development which we have taken place. Now, when we look this thing, and I think that Anwar has also told, one has to look at when you develop the technologies, that whole knowledge chain need to be understood. And this is the example when we looked at what are the different things which we need to do it. And then you prioritize which one is the most critical, which need to be handled first, because you can't do 10 things at one time, because then you don't have that much of resources and powers and all that. And also the trust by the business leaders. You know, anybody who puts the money first asks what you have done in the past. If you have done something in the past, then only they put the money. Otherwise, they don't put the money in science and technology. So this is also very, very critical over there. And that's why we selected the catalyst over there and product and application of that to have a technological leadership and also the growth directions over there. And the first example which I want to show, which recently in last 2 years have been commercialized, is a polyethylene technology, and where the catalyst has also played a very important role in Reliance, that we are able to develop a catalyst technology which is a commercially now operational in Reliance to make from ethylene to the polyethylene of different grades. And this technology is protected by close to, in total polyethylene, we have close to 40 to 45 patents in this area to ensure that we are not only doing the important part of technology, but nobody can have the litigations and other thing when we are commercializing over there. And I will try to, in 2-3 minutes, what is known, what we have told in 40-45 patents, we'll try to summarize in 2-3 slides. I think this is what just one slide which I said, I started the learning the polyolefin with Dr. Shivram, and the first publication with Dr. Shivram came in 1989 when I was in IPCL and started to learn the polyethylene polymerizations over there and try to understand the fundamentals of polymerization, which involve catalyst activation, the propagations and the terminations, and etc. And these fundamentals are very, very important when you develop the technology. If you develop the technology without going through the fundamental part, it will be extremely difficult when you operate that chemistry or engineering at a commercial reactor. So that's why most of the time, if your fundamental knowledge is not very strong, then when the challenges come in a commercial reactor, like example in polyethylene, this technology which we have developed today produce 90 ton polyethylene per hour. So this means whatever these steps which I have said, initiation, propagation, termination, they need to function continuously for 365 days, 24 hours in a reactor which is producing 90 ton of polyethylene per hour. So if any of this step is disturbed, you produce the off grade. So you should understand that this is where the fundamentals, and then how do you translate that fundamental so that that remains the same at such a high speed of that. And that's why I say fundamentals are very, very important, and these foundations are very, very critical to understand and see how do you take it forward to that commercial reactor so that you produce the right product, because customer is only looking for the right product, not the off-grade product, and which we have successfully translated this fundamental understanding which we started in 1989 in last 2 years to commercially produce the polyethylene. And we have gone through this learning of science and technology is not a one-step process. Every step you need to learn and see that knowledge is getting translated to the next level, and that's why the bench scale, pilot scale before you go to the commercial. And see what I have shown you, the fundamentals of mechanism that is getting translated at each of the stages without any problem, and we have successfully demonstrated that. And it is a great challenge, and that's why lot of patience, lot of commitments are required by scientists that to see yourself, and this work cannot be done by others. You have to see with your own eyes how this thing is getting translated, because if you have started the journey, you have to end the journey also. And that's why many times I get fascinated with Dr. Trivedi, because that's why he also, whatever journey he starts, he also tries to see up to the end. And I think that's why my training in Garda has helped me in a short period of time with Dr. Trivedi to how to take this thing and keep a patience and other things to see that it is translated. And today, we are producing close to 600,000 ton polyethylene of different grades using this technology over there. And different grades are produced, at a 90 ton per hour using our proprietary catalyst technology, which is protected by so many patents in this area and which is well now demonstrated. Now, this is recently, the FIPPI has given us the award Innovator of the Year for developing this technology successfully for polyethylene products. Because I think the recognitions are also very, very important in order to keep the motivating the team, and that's why not only you do the things and make money, but I think the recognitions equally become important. The second example, in just 5 minutes, I want to say the polypropylene. This is another case idea to market, which we have translated by earlier working and ensuring that we have different, in the technology also which we need to keep in mind, the customers are very sensitive to the products. They are always looking for best performance product. So in polymer, it is very, very important that as the customer demand expectation goes high, you need to change the product performance. Because if you don't change your product performance, somebody in the world will change it and customer will go over there. So that's why you will become irrelevant. So remaining relevant in a society, in a globally competitive, you should always be the leader all the time if you are globally competitive. And that's why we keep every 5 years, we are advancing this technology so that Reliance remain competitive in polypropylene products as compared to the global player over there. Otherwise, nobody is going to buy our polypropylene product if they are getting from somewhere else with a better performance. And here also again I want to demonstrate my first publication. And this is another example which I want to show that Dr. Shivram, I came because of Shivram to India. But after 6 or 8 months, I heard he is moving to NCL, And that was the most difficult time for me, that if somebody come back to India, because in India you don't come unless until you see the person. Organization is not important in my opinion. It is very important for scientists to work with the right person, Because if you don't work with the right person, you will never learn. Organization can be many and all that. So that the moment 6 months or 8 months I learned that he is leaving for NCL. And he told me that, Virendra, I am leaving, but you can also come to NCL, But I think leaving the organization is also not a solution. If you come, you should stay for some time to learn the thing. And that's why my first publication in polypropylene came in 1992, and spent 5-6 years to learn this polypropylene and understand the fundamentals over there. And now recently, we have developed next generations of 2 generations of catalyst technologies and product technology in Reliance. But recently, because as I said, every 5 years, the products are changing in the market. That's why your product technology should also change as a function of time. Now, last year, we have developed this advanced catalyst and product technology so that we remain competitive with the product which are coming from Lindell Basels and other. And I am happy that now this year we are producing close to 1.5 million ton polypropylene through this technology, and something around 25 grades for different application, which is passed through the concept. And this also we implemented from 25 ton up to the 75 ton per hour. This means those fundamentals of science, the propagation, the initiation, the termination, to have the consistency of the product should be applicable to these high throughput reactor system, which is operating from 25 ton per hour to 75 ton per hour. And we have ensured that in Reliance, this is all operational all the time and giving. And this clearly indicate if your foundations or fundamentals are correct, you have done the right chemistry and do have combined right chemistry with the right engineering, you will always get the right consistent product. And this is well demonstrated with the homo grades, fiber grades, and which you have seen last 2 years, this all mask and other applications. Then raffia, I think agriculture of food security. Sopan has already mentioned today working. And today, after understanding the science, we can increase the speed of lines also. Processing is also very, very important because we understand the fundamentals. Similarly, the impact copolymer grades today in automotive, lot of impact grade goes over there. We are able to fine tune the product characteristics as per the application requirement over there. And this is also last year, the FICCI has given us the Innovator of the Product Innovator Award. And also hydrocarbon processing has considered this technology to the top 5 technology in the world. If you look at XN or WR Grace, now Reliance's name is also there along with the Grace, another company in this area. So let me sum up what I try to show. The first thing that, which I always, thanks Dr. Shivram for polyolefin, brought me from US to India, giving me the opportunity to learn this chemistry of polyolefin. And then I personally took the interest to see that chemistry which I am learning get not only IP protected and other things, but get translated into the commercial success over there. And look at today that agriculture, health, transportation, energy transition, defense security. Energy transition, if you look at today, the ethylene, octane, copolymer, elastomers are emerging. And today, the Reliance is moving into solar energy, these polyolefin material or elastomers will become very, very critical for us. So this material will find a lot of application. And now, as Sopan has already told, that recycling and sustainability, this is a major focus which we are focusing on beyond that thing to, and probably in coming years, it is not the months things doesn't happen. It takes a year to provide the right solution which will emerge out. And then, what I try to show that today catalyst technology products application technology is already demonstrated. And in order to remain global leader, we are presently working on polymerization technology and recycling technology so that Reliance can become the first company like Lyndall-Bassell or the Dow or Univation to give the polyolefin technology to different organizations in the world. So thank you very much for your kind patience and hearing.
So to do the honors, I would request Mr. Sapan Ray to give the shawl and the memento to Dr. Virendra Kumar Gupta. Thank you very much. And it is always very exciting to listen to you.
Thank you.
So let us give a big hand for his achievements, for the achievements that he has brought to Reliance. Thank you, sir.
Yeah.
And the memento also.
I hope I've completed in a right time. Okay, once again, thank you.
Thank you very much, sir.
Thank you, Professor Pillai, to giving me the opportunity, to speak,
Thank you, Dr. Gupta. I think it was quite an enlightening one for many of us. Part of it I also didn't know, so I could pick up a few things. Our next session, next speaker rather, I'll put it that way, is Professor Bernhard Rhaegar and Dr. Claude Bonstein. Okay, I hope I'm pronouncing it correctly, from the Dutch Polymer Institute. We'll have this session online. They will join us online. So before we start playing, maybe I'll just give a very brief introduction of both the speakers here. Professor Bernhard Rhaegar is DPT's scientific chair for polyolefin research. He started his academic career at Ludwig Maximilian University of Munich and received his doctorate in 1988 there. I'll not go into details of his resume here or introduction here, and the other speakers for the sake of time. The other speaker is Dr. Claude Bostoin. He is the program manager for the PO program at DPI for almost 3 years. Dr. Claude Bostoin has a basic education and PhD in physics at the University of Antwerp. Again, I'm skipping the detailed introduction of them for the sake of time, and I would request my friend to start the online session that you have from them. Thank you very much.
Can you see my slides, please? Okay.
Yes.
All right. A good evening from Europe. So, and this on behalf of Professor Bernhard Rhaegar, Pooja Jagadish, who is our DPI person responsible for business development, and myself. So, as already explained by the chairman, Professor Bernhard Rhaegar is the scientific chair for the polyolefins program at DPI. And Pooja Jagadish is responsible for doing business development at DPI, as we are always seeking to have new industrial partners. We try to have people really focused on that activity. And as for myself, I'm responsible for the polyolefins program. And before starting our presentation, we would like to express our gratitude to the organizing and executive committee, and in particular, Dr. Virendra Gupta from the Reliance, for the kind invitation to present DPI at this symposium, which we see as a means to connect not only with the scientific community, but also to reach out to the polymer industry in India, which is a big market, more and more, and increasingly a market in the global arena of polymers. Also the committee for facilitating this online meeting. Thank you very much. So when we talk about DPI, we talk about shaping polymer innovation. So DPI shapes polymer innovation. Do you see my slides? Again, I just want to be sure that you are connected there. Okay. What we aim for is
could you also put it in the presentation mode?
Yep.
Yeah. Thank you.
Thank you, Pooja. Okay, DPI shapes polymer innovation. So we aim for better functionality, performance, and last but not least, sustainability. So how do we do this? Is that by, let's say, uniting industry expertise and academics excellence in a thriving ecosystem of pioneering researchers and innovators. Polymer research and innovation get improved quality and speed in the DPI community. So we mentioned the term sustainability. I think this is a very important agenda because what we have been doing the last 100 years is that we have been developing polymers in terms of efficiency. So everything has to be efficient at the lowest cost in order to maximize our returns. However, what we see in the tomorrow's world is that sustainability is a key parameter. And as shown in the graph at the right-hand side, we see that in 2020, a lot of our industry is fossil-based. And what we see for 2050 is a drive to zero fossil-based chemistry or polymer industry. And this will cause a tremendous pressure on, let's say, innovation, engineering, etc., to move this industry from, let's say, fossil-based to more, let's say, a circular, sustainably based business. And in line with the United Nations Framework Convention on Climate Change, we aim to be 50% circular by 2030. And in 2050, this should be 100%. Of course, these are very ambitious targets. In order to achieve these, we have to start now. And that's also where science and research and development comes into play. So what is the aim of DPI? What does it stand for? Is that we would like to fasten, let's say, the R&D process within the industry, and this by doing it together. So what we seek is that we get a general industry input from industry partners, and that via community-based research and innovation, we get results with impact. So these are rather generic words, but what we want to do is we first, with our industrial partners, define an industrial need. It can be, let's say, developing new analytical expertise. It can be, let's say, developing high throughput experimentation schemes, etc. What this industry needs is then translated into some kind of scientific challenge, where you would say, okay, let's go to a very fundamental scientific approach. And then what we have then is that we set out a call for proposals to leading laboratories in the world with a strong track record in the different disciplines which are relevant for the different programs. And we call for proposals so to get their ideas to solve those industry problems or to solve the scientific challenges. Then we have a selection and granting process of the projects. The selection is done based first by an industry committee, which tries to evaluate the industrial relevance of the proposal. And then on the top 10 or 15 projects which we receive, we, let's say, call university or let's say academic experts to review these proposals. Now, when this, you get a second ranking, and then again you get an evaluation in what we call a program committee, which combines, let's say, which is headed by the scientific chair, in our case, so Professor Rhaegar for the polyolefin program, together with the members of the industry, we get, let's say, a discussion and a final decision. And then the projects which are getting a grant are, let's say, they can start, and we started a monitoring process where, let's say, 2 to 3 years, times per year, they have to review the results. You get a discussion and evaluation by the industry experts, and so on. So, and this leads to an industry output which is relevant for them or not. And then subsequently, you get a new cycle of, let's say, innovation. Now, DPI has, let's say, 4 programs, 2 big ones, polyolefins and performance polymers. The polyolefins program will be presented by Professor Rhaegar. We have also a performance polymers program, which is more focused on the engineering plastics and more specialty polymers. And we have a smaller program, which is at the end and was getting at the end, let's say, when the oil prices were down, but maybe may get a new boost with the increase in oil and gas prices. So that's the polymers for oil and gas industry. And then fourth, but not the least, we have the Circular Plastics Initiative, which is organized in collaboration with an institute in the Netherlands on processing and technology. This is really focusing more on the circularity topic, developing new techniques, sorting techniques, etc. Under construction, we have sustainable polymers, which we would like to map now in the next coming months. We've been working on complex fluids. We will start up, let's say, our inquiry on functional and sustainable coatings, and also we have looked into biomedical. The point is that with these four, we really have to find out what kind of companies are interested, what kind of government fundings we may get, etc. And this takes always a lot of time. It's very challenging for our organization, but it's a very interesting one because you learn a lot of things about what kind of problems do different fields encounter, what kind of players are present, also the industry and the universities which are working on it, etc. So, but now I think I give the word to Professor Rhaegar, who is going to introduce us to the polyolefins program of DPI. Go ahead, Bernhard.
Yeah, ladies and gentlemen, to make a short statement, DPI's polyolefin program is a European activity from the Netherlands, but actually it's a program which is unique in the world. The reason for that is because we cover research from very basic conditions, basic research on catalysis, on polymerization kinetics, and on reactor design, all the way to new materials like ultra-rigid thermoplastics, high-performance elastomers, polyolefin elastomers, and even very important, more or less new developments like monomaterials, etc. And this has a strong impact because we heard now a couple of times how important the circular economy is. And I think especially for polyolefins, this is a big challenge, the holy grail maybe, to get a circular economy also for polyolefins. And this is a major topic that we address in our research programs. Next, please. We all know that polyolefins are important, but if we talk to people, then maybe they think that polyethylene or polypropylene that existed 20 years ago is the same in 2022, but this is not the case. What you see here is clearly that the European situation, that we have roughly 51 million tons of polymers produced, and you see on the left-hand side that the polyolefins make the biggest share, and mostly being active in packaging, but especially with polypropylene PP. Then you see that polypropylene developed and is still developing into a lot of other applications. We saw this also in the presentation from Dr. Gupta. And next, please. Next. And then you see that this is not only then a challenge in Europe. 20 years ago, 80% of the polyolefins were produced in North America and in Europe, and you see the picture now has completely changed. Now most of it comes from Middle East, from Asia. India has a huge part in that, as we heard before, but the challenges, next please, are enormous. We need new concepts for packaging, construction, mobility, electronics, fabrics, etc. So polymers will not be the problem, that will be part of the solution once we make them circular. And this is exactly the point. We need sustainable monomers, we need sustainable materials, and we need to be able to energetically or material-wise recycle the polymers. And this might be easy for other polymer structures like polyesters or polyamides, because you can easily hydrolyze them back to the monomers. Next, please. But I think what I call the sword of Damocles for polyolefin is that you cannot depolymerize them. You have a heat of polymerization of minus 100 kilojoules per mole, so no way to get the monomers back. But you have a high heat of combustion, minus 350 kilojoules per mole, and this might be part of a solution if we go to circular economy topics within DPI with our industrial partners, so that we maybe even just burn the polymers and use the CO2 to turn it back, or maybe use heat to cut the polymer chains smaller and then feed it back into the cracking process. But absolutely clear, polymers will grow and polymers will be needed in order to tackle all the problems that we see, for instance, global warming, increase of population, as we heard before. Next, please. Now, as I already mentioned before, these are the 5 major topics, and you see circular economy solutions for polyolefins are number 1. But again, we think we are unique, and we are unique because we cover all these different important items. Next, please. And we do this not alone. We do this together with 20 top universities and institutes, more or less all over the world, US, Europe, CIS states, and Japan. We have currently 25 PhDs and postdocs, 23 projects, and this is done and developed on a yearly manner. And we're doing this over 20 years now, and this is clear that this is a very broad point and accumulated expertise that we have in this field. Next. Yeah, we are a research platform. We combine basic research with the need of our industrial partners. We do the monitoring of the projects in 3 times a year. We have review meetings. We offer courses to train not only the academics, but also partners from industry, especially in all the details of polymerization and polymer technology. We sponsor networks. We sponsor and organize conferences on polyolefins like the Blue Sky Conference. So for all of you, next year in June 23, there will be one in a very beautiful place on Amalfi Coast in Italy, where we bring most of the important key figures from industry, from academia in polyolefin research together. This will be a fantastic event. Claude and I, we try to be an ambassador. So whoever is interested to join us in this platform, just let us know. Thank you very much for my part, and I give back to Claude.
Okay, now the polyolefin program, as all industrial programs at DPI, they cannot live without the funding of our industrial partners. So these are the industrial partners, the usual suspects, as you can see, and these are the people who are really giving the input, not only financially, but also on the topics they would like to have addressed in the programs, etc. They also give feedback to the students, to the presentations, and so on. And they also get into the discussions when we are discussing in detail some projects, etc. Now, as I already mentioned, we do not only have the polyolefin program, but also the performance polymers program. We have there also, and it's a little bit similar to what we see in the polyolefins program. We have the relation between processing, structure, and performance, which is very important there. Of course, recycling, reprocessing, and recovery is also an important issue, and that also related to sustainability, of course. Big part is also exploratory technologies and new modeling strategies for enhanced durability and performance. The modeling is there very important in that program. Now, the different partners involved in the performance polymers program consist of 3 groups. One are the material producers like DSM, SABIC, Beijing, and Kingfan. We have also converters of these materials such as SKF and Hutchinson, and we have the end users, which are Shell and Aramco. So it's a little bit different from, let's say, the polyolefin program, where we are really having the producers of polyolefins. Here we go also from, let's say, in the value chain, from material producers to end users. Then, as I already told you, we have a very big community, not only industrial partners, but also leading knowledge institutes. We are also, due to the fact that Reliance is on board for the polyolefin program, we are trying to reach out to, let's say, Indian knowledge institutes. So they are always welcome to apply for funding. So that's and that's also the reason why we would want to be here at this symposium, to reach out to the universities, but also to, of course, to the industries which are present here. Now, if we look at the DPI 2021 results, we couldn't be prouder. So if you look at the total project value, we come to an amount of 24 million with, let's say, 57 participations of industrial partners. We have 15 new projects in 2021 with 14 new academic partners. We have in total 48 projects, 85 researchers. We have, let's say, 3 new methods and tools which have been developed and have led to, let's say, an invention disclosure. And for 2020, we had about 39 scientific publications with 13 PhD theses. And the impact factor for 2020 was 4.7, which is quite high. Now, if there are any, let's say, questions or if there's any interest on your side, you can always contact me via my email address. And thank you very much for your attention. Are there any questions?
I think we may skip the questions and go to the next session. Okay. Next speaker, if I may invite there, Dr. Abbas Sheikh from SABIC. By the time Dr. Sheikh comes on the stage, a brief introduction of Dr. Sheikh. Dr. Sheikh has done his MSc in Organic Chemistry and PhD in Polymer Chemistry from University of Pune and NCL, Pune. He did 2 postdoctoral assignments, one in University Hamburg in Germany, the other one is at McGill University at Montreal in Canada. He is an author of 12 publications in peer-reviewed international polymer journals of high impact factor with more than 1,000 of citations. He has participated and gave presentations in various conferences. He is an inventor of more than 15 US granted patents. He has over 20 years of corporate experience in research at GE SABIC. He received his Management and Innovation Award for the new platform programs and technology development. Dr. Sheikh, it's a pleasure to have you with us. Over to you.
Yeah. Hello, everyone. Thank you very much for the introduction. First of all, I would like to wish Dr. Shivram 75th birthday wishes. It's a pleasure to be here to participate in this conference on the auspicious occasion of celebration of my Guru's 75th birthday celebration. In fact, I was also not a polymer chemist. I was an organic chemist, and I became like polymer chemist after working with Dr. Shivram. The credit goes to the Dr. Shivram. Well, before I start my talk, like I received a mail from Professor Vice Chancellor Pillai sir asking me to participate in this conference. Then when I accepted that invitation, but I said I just don't want to participate, but I also would like to present the work that we are doing on this auspicious occasion. And then that is why I got this opportunity to participate and to share some of the research that we are doing in this corporate organization. Can you just please show a slide? Okay. All right. Okay. Well, my research career started working in the field of polycarbonate, and I'm going to talk about the same subject. Like today, Dr. Shivram mentioned that you keep moving. I mean, we should keep changing the field. I try to do that. I mean, I worked on different chemistries, blends, products, and finally I ended here. I'm working on this polycarbonate. This is, like a collaborative research that I have been doing with one of our senior-most scientists of our organization. His name is Theo Hooks. Why I'm mentioning his name? He occupies the highest technical position in our organization. He has developed many technologies, delivered technologies to the organization. Most importantly, he has also worked collaboratively with Dr. Shivram and Dr. Prakash Vadgaonkar for developing technology, and they have already delivered a technology for automotive anti-static product, and that technology is as of today in the market. And when I said I think we should present, then immediately Theo said, I think we should participate, not only participate and share our efforts. That's how, Theo, I just want to show here. Okay. Now, what I'm going to talk about today is the functionalized chemical resistant blend of bisphenol A polycarbonate. Well, we know bisphenol A polycarbonate is one of the high-performance polymers. Today, Dr. Prakash Trivedi talked about the outstanding performance polymers. Well, this is the exceptional polycarbonate, which has a unique combination of properties, which I'll talk about. Okay. Well, before I talk about the chemistry, the polycarbonate, the precursor, the monomer for making the polycarbonate is bisphenol A. This bisphenol A is a simple reaction of 2 moles of phenol with acetone. What you get is a symmetrical molecule which has 2 aromatic groups, 2 methyl groups, and 2 phenol. And the byproduct in this reaction is water. And this was first reported by a Russian chemist Alexander Dynin in 1891. And we talk so much about the green chemistry, green technology, but in my opinion, this was the one example. You can see that in 1891, the chemistry that is reported used to, I feel it's still a green chemistry technology because the water is a byproduct. One of the reactant acts as a reactant to the reaction medium, and one of the reactant also acts as a crystallizing medium. That is how this molecule is a technology, green technology. Well, the importance of this molecule was realized after making the polycarbonate, bisphenol A polycarbonate, and that was done by a scientist, Daniel Fox, in 1953, who was a scientist in GE, and he is regarded as a father of polycarbonate. Well, since then, of course, high-performance polymers have the attributes, but if you look at the bisphenol A polymer, this has many attributes. One of the important attributes is like glass-like transparency. If you look at the refractive index of water, it's like 1.33, but this has higher. That's why we call this as a water-like polymer. It is quite tough, strong, and stiff. This is easily processable. It is dimensional stable. Yeah, these are the many attributes. One of the most important attributes is the clarity and the high impact strength. Well, over the years of the working on the various products, especially the outdoor applications, what we realized is that when this polymer comes in contact with UV, it has an influence and it has a yellow color. Then this polymer also, though it is it has a transparency, good impact, but it's very susceptible to chemical, and it is a scratch prone. Well, that's why I'll talk about one of the aspects that we try to improve by doing the chemistry, by making blends. Again, coming to the bisphenol A, I like this molecule because since this is a technology, because the importance was realized after making the polycarbonate. This became a very important precursor. Whatever the BPA is produced commercially, around 67% goes for making the polycarbonate. Next one that goes for the epoxy and others. And now there is also a lot of development in terms of technology, where earlier the acid was used as a catalyst, but now they're using the cation exchange, the resin as a catalyst. Well, this molecule, I also got introduced during my PhD training. I also worked or played with this molecule for 3 years, and we came up with a number of inventions with this molecule, bisphenol. Okay, yeah. Now, for the benefit of the students here, I just would like to talk about the technologies that is currently practiced to make this bisphenol A polycarbonate. The first one is the interfacial polymerization. This is very well known, the polymerization. In this process, what we do is we take the BPA, we make the salt of that, and it's a biphasic system where the reactive monomer, the condensing agent that is a phosgene, is bubbled, and the salt of BPA from the aqueous phase comes to the organic phase, and that's how you get the polymer and the formation of, there is a formation of the byproduct, that is sodium chloride. The merit of this reaction is the reaction is very fast. Well, it happens at ambient temperature, and one can make a polymer of any molecular weight range by this interfacial polymerization method. But the only demerit or drawback is we use toxic and hazardous phosgene, that is the reactive molecule gas, and we use a lot of the solvent, chlorinated solvent. Since we use the solvent, this requires a lot of removal of that. Then the byproduct has to be removed, and that's why you need a lot of separation to get the pure polymer. Now that's why now the next the technology developed is the melt polymerization, where we totally avoid the use of this solvent, where the bisphenol is condensed or heated with the another derivative of that phosgene, that is diphenyl carbonate. And this is an equilibrium reaction. It is heated or it's done in presence of a catalyst, and this equilibrium is driven by the removal of the byproduct phenol. And again, this phenol can be reused to make the bisphenol A, or this can also be used to make diphenyl carbonate. Yes, the merit of this is, we use the organic carbonate like diphenyl carbonate, which is there is no hazard, and the most important is it is a catalytic process. And as I said, the byproduct phenol can be recycled either to make the diphenyl carbonate or BPA. This is solvent-free and it's a continuous process. The interfacial polymerization is kinetically driven, whereas the melt polymerization is thermodynamically driven. Of course, when you do this melt polymerization at a high temperature, certainly there are some of the drawbacks. Here, the monomer that is required to make this polycarbonate is required very high purity, otherwise it's very difficult. And also the stability of the monomer is important to get the polymer of required molecular weight. And another demerit is the catalyst which remains in the polymer, because though this is a high performance polymer, but it's very sensitive to any of the impurity that is present. What I want to say is, these are the two technologies were developed like interfacial polymerization as well as melt polymerization. Because of the toxicity associated with the interfacial polymerization, there is a shift to the melt polymerization where we don't use this chlorinated solvent or a toxic chemical like phosgene. These were the two technologies that were developed in Europe and US. Okay. Now, as I said, diphenyl carbonate, which is a precursor, is an important precursor to make the polycarbonate. But to make the diphenyl carbonate, that reaction is a thermodynamically unfavorable equilibrium reaction, and therefore there are a lot of efforts are ongoing. Of course, there are companies like GE Sabic already they have commercialized. There are some methods by which this diphenyl carbonate is made, and still there is a lot of scope. If someone can come up with a technology to make the diphenyl carbonate at a like a convenient or very good yield and selectivity, that is going to change the technology or the perspective of the polycarbonate. All right. With this, let me move on. I think earlier I said there are the two technologies. One is interfacial polymerization and the melt polymerization, which was developed in Europe and US. here is the technology that has developed, which is a green and sustainable process where it started from the polycarbonate. I think our Virendra Gupta talked about the ethylene, polyethylene. Here, ethylene is converted to ethylene oxide, and then it goes through the ethylene carbonate. We make the dimethyl carbonate and ethylene glycol. Then that is the one where you can make the dimethyl carbonate from CO2. Then the DMC can be converted to DPC, that is by reactive distillation. Earlier, as I said, this reaction is very thermodynamically unfavorable. We get very low yield and also the selectivity. But by this reactive distillation, this assay, they were able to push this product of good quality as well as they are still a little higher yield, but still that requires further development. The last method where the polymer is made by the gravity utilization method. The conventional melt polymerization method, it requires complete mixing to drive the reaction and remove the byproduct. But using this innovative gravity utilization method, which is a non-agitation method, by which we can make the polymer easily and you can get a good quality polymer. And this also has a sustainability aspect where you start with CO2 and you get a polycarbonate where all that CO2 gets incorporated, which means if we make the 10,000 ton of polycarbonate, around 2,000 ton of CO2 is emission stopped or is consumed in this polycarbonate. This is what is this is a recent technology that has been developed by SI. There are almost like 6 to 7 plants that are running. This is one of the plants that is the technology is licensed to Kingdom. I'm also associated with this technology for the past 3 years. There is a lot of learning on this. All right. Okay. Then I talked about the technology, the recent technology, and then where this polycarbonate goes. As you can see that this characteristic chart shows the various applications of the polycarbonate in different areas, but most of the applications are the application of this polycarbonate goes for the transparent application. This chart is a little bit pre-COVID, but in the post-COVID, this must have changed because a lot of application for the healthcare has increased on the polycarbonate. Because so far we are focusing on, especially in the healthcare, like antimicrobial, antifungal, but now there are a lot of efforts. You'll not be surprised if you get a polycarbonate shield or safety things, which is like antiviral. Those types of efforts that are going on. Okay. All right. I talked about the polycarbonate. Let me talk about the other polymer which is there in our portfolio. This is the polyester, which is PET is the largest volume made polyester. PBT is another polyester which is there in our portfolio, which is made from terephthalic acid and vitriol. This polymer is semi-crystalline, which is opaque in nature. And of course, this also has various key attributes like, it has chemical resistance, better flow, good weatherability. Whereas polycarbonate doesn't have that much good chemical resistance. And of course, since being this is opaque in nature or semi-crystalline, this polyester or PET goes to a variety of key applications, in most of these opaque applications. Okay, why I talked, okay. Now, as I see that, I want to show that this polyester, which has the acid N group and the OH group, as you know that the epoxy is used for the coating applications, but we know that the epoxy reacts with the acid. This is an addition reaction that happens easily under the reactive oxygen conditions. And we have done an extensive study of using various types of epoxies, like alkene-based, ether-based, or acid-based. These epoxies differ in terms of the reactivity. The ester-based epoxy is the most reactive, and the reactivity of the various groups, that carboxylic acid is very fast. Why I'm saying that, if you take the polyester and add the epoxies, you can functionalize. Now, when you take the two polymers mixed together, I think you can end up with a different perspective, like you can get either miscible, compatible, or incompatible. But we wanted to make a blend which is compatible, where we can combine the properties of the best properties of both the polymer. For example, polycarbonate has a good impact, clarity, and high heat properties, whereas polyester has chemical resistance, superior weatherability. By doing this, we thought we can tailor-make these properties, or we can get the improved properties combining from both the polymers. Well, as you can see that when we try to make the blend of the polycarbonate and polyester, this is very well documented in the literature. This undergoes different types of reactions. One is direct ester and ester carbonate interchange, alcoholysis, and acidolysis. And when we try to make the blend 1:1 proportion, it leads to formation of, due to transdistribution, it forms block copolymer, random block copolymer, and then it gives us statistical polymer. So what I'm trying to say is, if you mix polyester and polycarbonate, you can get a compatible blend. Well, having understood the technology, the chemistry associated with the polyester epoxy, what we tried to do in our case was we tried to functionalize the PBT, taking the allyl glycerol ether epoxy. We just added 1%, and we did the reactive extrusion. As I mentioned, this reaction happens, in the extrusion condition is less than 1 minute, which is very facile chemistry. We added around 1% of that, and what we found was, based on those property evaluation, what we found was there was effective functionalization, and when it functionalizes, these are the intermediate, those isomers that forms ester alcohol products. Then we want to take that and make the blend with polycarbonate. Of course, this was confirmed through the COSI by our NMR expert. We showed that formation of those two isomers. Then we took that functionalized PBT, and then we made this blend with the polycarbonate. This table shows the complete property evaluation of that. As you can see, what I want to really stress here is that when we made the blend, we could get improvement in the flow properties. We could also retain the properties of polycarbonate, like that 80 to 90% transparency. That was the main objective. Then, we also looked at the microscopy studies at the macroscopic level, what is happening. As you can see, the PBT particles is distributed in the PC matrix, and the pellets and the molded parts, you can see that those particles are very stable, which means it's a chemically compatibilized stable blend is formed. And then this is the final, the chemical resistance, we did that. The 11 formulation is the PC, that 9 and 10 is the blend with the allyl glycerol functionalization. As you can see that we could get elongation retention properties better than polycarbonate, which means we could get the chemical resistance through functionalization. Well, in summary, I can say that we could make the blend product, retaining the, combining the properties of the polycarbonate and polyester through functionalization. Of course, there is a further way to do further functionalization that we will be doing, or that is in the plan. And you can see that the molded part is transparent. And interestingly, we could publish this paper. It's in the press. Those who are interested in it can refer this. For this, finally, I would like to thank our leadership, which helped us to participate and support my manager, and then my Theo's manager, who is in Europe. And of course, I would like to thank Professor Pillai for giving me an opportunity, as well as the Society for Polymer Science chapter. Thank you very much for your kind attention.
So I would request Mr. Sapan Ray to present the memento and the shawl to our speaker. Thank you very much, sir, for being with us. The memento also, sir. Yeah, this gentleman. I think
Okay, we have the next speaker, Dr. Subarna Shamroy from Asian Paints. Shamroy, yeah, great. Dr. Shamroy has been on various leadership roles at R&D in Asian Paints. He has a PhD in polymer chemistry from National Chemical Laboratory, Pune, and postdoctoral fellow from University of Massachusetts, Amherst, and Tulane University, New Orleans in USA. Dr. Suvarna worked with GE India Technology Center at Bangalore and Reliance Industries Limited, Mumbai in various capacities before joining Asian Paints Research and Technology Paints Research and Technology Center in April 2016 as head of the department. He has an end-to-end responsibility of sponsoring and overseeing projects, managing vendors and suppliers, supervising scale-up and production, interfacing with plant, supply chain and marketing, and participating in customer market trials. I will probably skip the next of this thing for the paucity of time, and over to you, Dr. Shamroy.
Yeah, very good evening to all of you. And I'm standing between you and Dr. Sivaram's felicitation program. So I will try to see how I can accelerate my speaking. I represent Asian Paints. It's a paint company, the first tire paint company of India, and also a first tire paint company reputed in the whole world. Our ranking keeps changing, but we always are around in the first fifth in the world. Now, this is a polymer conference and a conference in respect of Dr. Sivaram, who has dedicated his whole life to polymer chemistry. So I asked myself, I work for a paint company, so what am I going to talk about here? So then I decided that I want to give this audience an idea about what polymer chemistry does in paints and what we do in Asian Paints in polymer chemistry every day. So I thought this is something which I love to do every day, and it is also very befitting for the occasion as well as to Dr. Sivaram's birthday celebration. No, it has worked. Thank you, sir. Yeah, so I start with this kind of a tagline. So coating is nothing but a liquid processed and liquid applied polymer composite that cures either as thermoplastic by evaporation of solvent or water that carries the whole paint as a vehicle, or as thermoset with crosslinkers. So that's where polymer sits in the coating. On an average, every coating product has around 30 to 50% of polymer into it. There are some very, very bottom of the pyramid kind of coating products which has lesser polymer, but this is the average wet percent. And predominantly, all the functional properties of the coating, except for the opacity part, because when you apply a paint or a coating on a substrate, you don't want to see the substrate behind. So that opacity part and the color part, that comes from the pigments. And there are some pigments, extenders and fillers which also impart some amount of other functional attributes, maybe corrosion resistance or some other functional attribute. But the predominant bodily properties of the paints and also the predominant surface properties, because when you apply a paint or a coating, the surface is very important. What are you getting from the surface? Whether the surface is very smooth, whether it is glossy, it has a sheen, or it's a matte, because these are very important consumer attributes for any paint and also for any industrial coating as well. So all those properties in the paints come from polymers. And there is, of course, so most of the paints and coatings are, like I said, liquid processed and liquid applied. Of course, there is an exception category, which is powder coating, which is extrusion processed, solid applied by spraying the solid powders with electrostatic spray. By electrostatic attraction, they go and sit on the substrate, and the curing happens when they are melted on the substrate. The substrates are stoved inside of a stove or a baking oven, okay, in industrial scale, and there the curing happens. So that's an exception. And today, Abbas just talked about how carboxy and glycidyl functions react. The carboxy functions of the polyester react with glycidyl function. Incidentally, majority of the powder coating industry depends on that particular reaction. Majority of the powders, maybe about 50 to 60% of the powders, they are carboxyl functionalized as terminals, and they are cured by various epoxies. The distinction from what Abbas just showed to us was that he was getting the epoxy reacted inside of the extruder, but in case of powder coating, we mix the polymer, solid polymer, and the solid epoxy and the solid catalyst, everything, and we extrude it to make a mixture, but we don't allow the reaction to happen over there, instead of everything being there. We get the product out of the extrusion, we grind it into a powder, and sell it to the industrial customer. At the coating processing end only, the reaction happens. So it's designed that way. So I'll just go to my next slide. I think the movement's a little slow. So these are the few things that I will try to cover in this short period of time. So what are the key polymer categories or the workhorses in the paint and coating industry? One are the aqueous emulsions, or predominantly all the residential or building related, we call it masonry paint. All the masonry paints are predominantly from emulsions, whether it is for the exterior walls or for the interior walls. All the shiny paints that we see on our grills and our doors and windows and all, they are predominantly enamels. They are all alkyd-based enamels. So emulsions and alkyds are big workhorses for the paint industry. Just to give an example, in Asian Paints, we produce about 500,000 kiloliters of emulsion-based paints, and a closely competing, if not more, quantum of alkyd-based enamel paints. And we produce, so like I said, all those paints contain about 30 to 50% of the emulsion and alkyd polymers respectively. We also make those emulsion and alkyd polymers ourselves. Although we have the opportunity to buy all these polymers from various suppliers, but it's a matter of choice. You can either make all your polymers and use captively, or you can buy polymers, so we go for the first choice. What we get from the suppliers is plethora of interesting monomers and macromonomers to make all these polymers. That's the interest that attracts us. Then we have another category of polymers called dispersion polymers. I will show some examples of that later. Dispersions are also aqueous polymers. They help in making water-based paints. However, they are surfactant-free. Then we have liquid and solid polyesters. So alkyds and polyesters are close twins, you can say. Alkyds are nothing but vegetable oil modified polyester backbones. And solid polyester I talked about in my previous slide, that is the powder coatings. Then we have the polyurethanes, and we also delved a little bit with non-isocyanate polyurethanes. I'll talk about it later, because generally polyurethanes require a toxic chemical called isocyanate for its curing. Then we have the coatings inspired from nature. And I'll talk about a little bit on the hybrid polymers. I don't know how much time I'll be able to devote in each section. Now emulsions, I think anybody interested can read through it. I'll skip most of them. See, basically emulsions are surfactant stabilized polymer particles in water, having well-defined particle sizes as per our desire. We control the particle size by the surfactant dosage and the process technology. And we mostly make, in Asian Paints, we mostly make acrylic and styrene acrylic based emulsions. Of course, there are various other workhorse emulsions for other industries like SBR, PBR, and then there are VAM based emulsions. We also make a little bit of VAM based emulsions also, because we are also a player, key player in the adhesive segment apart from Anubhav's company. So we also make a little bit of that. So acrylics, styrene acrylics, and the VAM-based emulsions are our predominant emulsions. Areas of innovation in emulsions are actually in the structure-property relationship, playing with the structure-property relationship. Choice of monomers, like styrene, you have got various acrylates, methacrylates, butyl acrylates, 2-ethyl exyl acrylates, many long-chain acrylates, many silicone acrylates. You have got polyethylene glycol terminated acrylates. So many are there. And then the processing steps and sequence. And then the particle morphology, like you can have a emulsion where the whole latex particle is uniform from center to the periphery. You can have different composition in the core and a different composition in the shell. You can have inclusion emulsions as well, where in one shell there are multiple cores. All these morphologies can be made. Then there are the surface chemistry that also comes from the peripheral surface chemistry of the particles. Then we have the polymerizable surfactants also. So you can have surfactants which get built into your polymer backbone. So these are generally the areas of innovation where we play every day. Then some of the special monomers, I think I just gave their names. So monomers define many things about the properties. Just a few examples, like polar monomers like acrylamide, ureadoacrylate, hydroxyethyl methacrylate, polyether terminated acrylates. You know, they give hydrophilicity, they give very good substrate adhesion, etc., etc. Then there are cyclic, bicyclic, all those things are there. So this I have already told you. So some of the things I would like to highlight here that, see, all these emulsions that we make, as you saw, apart from the 50 wet% of water that it carries, generally there is hardly any renewables in there. You know, most of the monomers and surfactants, ultimately they're all fossil fuel sourced. However, you know, for example, Evonik has given us some few monomers which have got certain percentage of bio-derived, content. You know, let's say isobornyl acrylate or the C13 methacrylate, they're also available regularly from fossil fuel sources. However, Evonik has created equivalent molecules which have got this much percentage of renewable resource in the back end. Then we have ourselves tried to put a lot of sugar-based molecules, sugar-based small molecules as well as sugar-based larger molecules inside of the emulsion. Okay. See, sugars have all hydroxyls on their surface, the sugar-based, either the monomeric molecules or the polymeric sugars. So they can be made to have certain synergistic non-covalent bonding with the backbone functionalities of emulsion polymers. And there are also ways to connect by cross-linkers the surface functionalities of the sugar and the surface functionalities of the acrylic emulsion particle. So that's how we have developed some of them, and we have some patents also over there. The patents are referred at the bottom. Alkyd resins, I'll not go into the detail of the mechanism. Mainly, alkyd resins have 30 to 60% of vegetable oils built into polyester backbones. Now, vegetable oils have conjugated as well as unconjugated double bonds, which in presence of certain metal organic compounds, which are called dryers, they give rise to C radicals as well as O radicals and hydroperoxide radicals. And through their radical-radical combination, after the coating is applied, the individual polymer backbones cross-link, and that's the hardening happens. That's more or less the alkyd chemistry. Now, areas of innovation and sustainability in alkyd is that, see, in alkyd, unfortunately, although there is 50% polymer and out of which so much percentage is oil, but we have got rest about 50% mineral turpentine oil, which is not renewable. It's a fossil fuel based source. There we can't do anything, but there we are trying to disperse the alkyds in water. That's a different story. But other than that, we can still increase the renewable content of the alkyds through various innovative molecules like cardinol, which is cashew nut derived, then again sorbitol. Alkyd has, apart from the glycerol, which is bio-derived, alkyd also uses various other polyols, penta, TMP, and all those things. So we have actually replaced, in certain compositions, we have replaced 100% of those polyols at least by sorbitol kind of molecules. Okay, so these are some of the patents that we have had in the alkyd section on the renewable related innovations. Then now come the dispersion. I'll just touch upon the dispersion technology and move on. See, dispersion is where you make an ionomeric polymer. You can make an ionomeric alkyd, you can make an ionomeric solvent-based acrylic polymer. Any polymer you can make ionomeric. You can make an ionomeric polyester also. So then, let's say you have a carboxylated polymer, then you convert into its salt by neutralization with either ammonia, caustic, etc., etc. That salt I can take it into the water, depending on the molecular weight control of my polymer. So that's the dispersion technology. It does not require any surfactant. So, and like that, we have got alkyd dispersions, acrylic dispersions, even polyurethane dispersions, one component, two component. So polyurethanes are either linear or branched polymers, condensation polymers of polyols and polyisocyanides. And then we can incorporate some carboxyl dangling polyols in between, and then we can make carboxylated polyurethanes, and we can neutralize them with ammonia or caustic, and we can get it into an aqueous phase. That's a very good technology for polyurethane dispersions. So we make them. Then there are a whole bunch of polyesters. Now, see, a little differently from the typical thermoplastic polyesters, which are workhorses of the engineering thermoplastic industry, like fibers and bottles and all, where it is predominantly polyethylene terephthalate. The coating polyesters are highly decorated with various polyacids and polyols. Now, there are opportunities of incorporation of isoprenoid polyacids like rosin and all, which we do. And then the curing of the polyesters are also interesting. They are cured by epoxies, they are cured by NCOs, and they are cured by various other things. They can be cured by melamine formaldehyde, urea formaldehyde, and all that. All those chemistries we are playing daily. Now, one interesting thing that I would like to highlight is that recently in the last 2 years, in certain powder polyester compositions, we have incorporated up to 25% of recycled polyethylene terephthalate. that is recycled PET bottles. Okay? And we have commercialized it. So far, we have sold little quantity of that, only about 50 ton in the last year of that polyester. So 25% of that is actually recycled PET chips. Now, we are increasing that volume in the next 2 years' time to around 500 tons per year, which is, in totality, it may look like a small but then it will consume about 100 tons of PET chips every year, recycled PET chips. So we feel proud to do that contribution to the environment by this kind of research. And in terms of actual implementation of this technology, we are in the paint area, because paint, the polymers have to be made within certain handleable viscosity, because it's ultimately, it cannot be a high molecular weight engineering thermoplastic. So in this domain, the actual commercial application of recycled PET chips incorporation, industrially we are one of the first, we can say. In India, of course, we are the first. Globally also, we are one of the first few. Because the incorporation of the PET chips requires certain technology handling. It has to be first glycolized with certain desired polyols. Then there is a huge bulk density difference between the chips and the other polyester. They have to be mingled together and all. I'll talk about a little bit about what we did on non-isocyanate polyurethanes. So like I said, polyurethanes use this toxic chemical NCO, isocyanate. That's an inseparable and indispensable composition of a polyurethane chemistry, whether you make solid polyurethanes or you make polyurethane coatings. Now, in the late 90s and in the hundreds and the early 2000s, research reports came out where people established something called a NIPU chemistry, non-isocyanate polyurethane chemistry, where glycidyl reacts with carbon dioxide under autogenous pressure at certain temperatures to give a cyclic polycarbonate. When you react a cyclic polycarbonate with polyamines, you get polyurethanes, carbamate linkages. The only difference is that when you react an alcohol with an NCO, you get only NHOCO, whereas here you get also a beta hydroxy group extra. You can see from this structure, there is a beta hydroxy group, maybe there in that circle you can see. So this is actually a beta hydroxy polyurethane. But the beta hydroxy group does not hamper in terms of the polyurethane properties. However, beta hydroxy group actually presents certain newer opportunities for curing of this kind of For example, we made the epoxidized soybean oil is very easily available, commercially available. So we made a polyurethane, non-isocyanate, from the epoxidized soybean oil, and we get this kind of beta hydroxyurethanes, and then we use the supramolecular chemistry to cure them. We made another highly carboxylated acrylic resin, and there is a supramolecular curing, supramolecular hydrogen bonding between the carboxylic acids and the beta hydroxyurethane units. So that's how this liquid material, when blended and applied as a coating, along with another carboxylated acrylic or a polyester or an alkyd resin, we get a hard coating. Okay. So we have filed about 4 or 5 patents on that also. We have protected this technology. This last one is about there are various other curing systems we have developed out of it. The last one is about that supramolecular curing. Then coatings inspired. Yeah, I have to now maybe, I'll curtail some of the things in the other end, towards the end. So coatings inspired from nature. One is the rust encapsulating coating that I would like to, is very close to my heart. See, this mussels have catecholic moieties on their feet, and because of which the catechol can adhere and make dynamic non-covalent bonds with the various kinds of substrates because every possible substrate, whether it's a silicated substrate or a metal substrate, most of the substrates have some surface hydroxyls, okay, and various other surface functionalities. So catecholic moieties make very strong multiple hydrogen bond kind of bonds with them. So we got inspired from there. What we wanted to do is that we wanted to dangle catecholic moieties out of our emulsion polymers so that my emulsion polymer can directly use the rust on a grill as a curing agent. Because mostly when we apply enamels, why do we apply? We apply because we have to protect it from rust, apart from the aesthetic part of it. And then we apply some anti-corrosive coating, then some primers, etc., before we apply the enamel top coat. Here what happens, now I cannot use costly catecholic moieties. There is a very nice catecholic moieties like dopamine, which had been available to me. I would have easily put it on a polymer backbone, but that's not easily available commercially. Then we took a simple molecule called gallic acid, okay, which is even better than catechol. It has got 3 phenolic hydroxy, and it has got 1 carboxyl group. Now I make a cationic ionomer emulsion, which has got amine dangling amine pendants, okay. Then I cook it along with the gallic acid. Again, I get a very strong hydrogen bonded interaction between amine and acid. It is almost like a single molecule. And then that polymer, when it is applied on rust, whether it is Fe2O3, which is a fresh rust, or Fe3O4, which is a very aged rust, very hard rust, it completely encapsulates the rust and increases my enamel anti-corrosion property by almost 100% extra. So we have also protected this technology, which is a nature-inspired technology. Another nature-inspired technology area is superhydrophobicity and superhydrophilicity and increasing light transmission. I'll just touch upon. Moth eye is another very inspiring material science. It has got such a nanostructured surface that it does not allow any light to be reflected. Moths can see in the darkest of dark because its nerves can receive the faintest of light because nothing gets reflected from the surface of moth's eye. It is purely because of the nano-textured surface. Okay? So nothing gets reflected, everything is transmitted inside. So we created this kind of surfaces in the form of anti-reflective coating. Okay? There are, of course, market benchmarks, known companies which make anti-reflective coating on solar cell glass panels, where, see, the bare glass has a light transmission of about 90%. Now, if you can increase this 90% transmission to just 2 to 3%, calculation says that you actually harvest a lot more energy from the sunlight. If you allowed 10% light to get reflected, you lose a lot of energy. Instead of that, if you allow maybe 5–6% light only to be reflected and rest transmitted, you make a much better harvesting. So we made that kind of coatings by pure inorganic polymer chemistry and then creating in situ nano indented coating on the glass surface by first depositing the right inorganic polymer matrix onto that, which forms a film, and then calcining when certain components gets out and the other component remains, thereby giving this kind of nano texture surface. And we are able to get up to 93% light transmission from 90%. We are working towards 94%. This is even 1% increasing also very difficult. So it is work in progress. Then there is the other nature inspiring thing, is the superhydrophobic, superhydrophilic. I cannot go into the detail of that, but then we have touched upon super omniphobic contact angles of iodomethane 135 and water 134, pure omniphobic is 150° plus contact angle. And then we have also been able to touch, okay, next slide. Okay, that's a different one. There is another coating which is a hydrophilic coating. I'll come to that later. Yeah, I think this is the hydrophilic part. Yeah. So here we have been able to touch up to around 75° contact angle, which is a hydrophilic. Here the chemistry is that, yeah, on the polymer backbone we dangle not in a very periodic manner, but on a random manner, but we dangle polyethylene glycols by graft polymerization. And when I apply that polymer and cure it as a polyurethane, the bulk of that polymer is extremely highly cross-linked polymer, highly cross-linked coating, which gives all the bulk properties, and it gives stain resistance of all organic stains that you can think of. But the surface is hydrophilic. It's kind of a monolayer hydrophilic surface, which gives a surface contact angle of 75° with water, because of which water forms a sheet on this otherwise hydrophobic coating material, and hence rainwater can clean all the dust and the soot and everything that deposits on the coating. This technology also we have patented and protected. Hybrid polymers, I think today I have to skip, but there are very interesting hybrid polymers that the paint industry is working upon, and we are also working upon. Let me go straight to my acknowledgement, which is very important. So I acknowledge all the work that I am able to do in Asian Paints to the whole Asian Paint R&D team. Every morning I go to office in one of the 8, in each of the 8 labs that I own, some or other new macromolecule is being made. So that's the pleasure that I drive every day as I go to office and come back from office. So Asian Paint has given me that platform to me and the whole R&D team. So I report into the R&D head, of course, and I look after a few departments which are predominantly related with the polymers part. Now, we have a dedicated R&D center of a 6-acre campus. We have total around 230, close to 230 employees, including managerial and bench executives. And we have total now 25 PhDs. We have about 86 national and international publications, almost 50-50. We have so far filed 96 patents, starting quite late in the last couple of years. And out of them, we have got granted so far 39 patents. And we have a promise, it's our charter, that by 2025, we want to see our company having a portfolio of minimum 150 patents filed and some of them granted. And our charter also says that what is the strategy of patent filing, or what is the output of patent filing. So we want to see that 25% of our patent portfolio should be commercially implemented into products and technologies. So that's the kind of research environment that I'm blessed with to work in. So with that, with my, again, gratitude to Asian Paints, gratitude to this audience, and Professor Pillai, and also to Dr. Sivaram, who has built me. So I end my talk. Thank you, everybody.
The technical session, I would request Mr. Sapan Ray to give away the shawl and the memento. And also the memento, sir. So now we move on to the most exciting part of today's events, and that is Professor Dr. S. Shivaram's FISH session. And this shift session, I would request to be chaired by Padma Shri Dr. G.D. Yadav, who is the ex-Vice Chancellor of ICT, to come on the dais. I would also request Professor S. Ramakrishnan to come on the dais. And of course, we would request Professor Dr. S. Shivkumar and Mrs. Rama Shivaram to be here. Shivram. Sorry, there was a slip of tongue. Professor Shivram and Ramaji to come on the stage, please. Sir, please. Now, as we know, we are here to have the felicitation of Professor Shivram. I would request Mr. Saten Daga of Daga Global Chemicals to come on the dais and say a few words. Mr. Daga, please.
Thank you, Professor Pillai, for giving me this honor to speak in front of my gurus. You know, since morning, I'm from a commerce background, throughout 40 years of chemical trading, and sitting in front of an intellectual class like this, you know, it becomes a pleasure, learning chemistry all 40 years. So how to pay tribute to my gurus? So I would like to draw two lines from Sant Kabir Doha. Guru Govind Dou Khade, Kake Lagu Paye, Balihari Gurudev ki Govind Dev Bataye. Sir, I must say you that I'm privileged to have Dr. Shivram as my guru and guide. We are starting a manufacturing company, and he is guiding us thoroughly. When I sit with him, I sit like a student. The only challenge we feel is 20 years in China also, that how industry and academia collaboration can be increased. And there I feel that I'm privileged that my startup manufacturing company is having two projects, one with IICT and one with NCL. Professor Lily is not here. I would like to throw some challenge to this young crowd, how to reduce dependency on China. 60–70% is still there. So how industry, academia can come together and reduce our dependency on China. And if I feel that this kind of intellectual class, if it is there, if BSc and NSc can allow to create an intellectual capital like this, will beat an Nifty index also. Thank you very much.
Thank you, sir. Now I would request Professor Anil Kumar to come and say a few words. Professor Anil Kumar.
Good evening, all. It's an honor for me to be here for this important event, and it's wonderful to see Professor Shivram here. I met him first time in 1991 when we started the Macro 91 event. So I just joined as a PhD student at IISc Bangalore, and that was first time after a few months we went for a conference, and that was at NCL Pune. And from there onward, we have been very regular in all the macro events. So it's been a wonderful journey for me to learn from him from the very first early stages of the PhD and all the way to build up the career, then join as a colleague at IIT Bombay, and then again started learning from him. So it's been a long interaction of 30 plus years, and I really thank sir for many more years to come and contribute to the society. We need him at least minimum of 25 plus, and I hope we continue to get his guidance for another 25 years plus to that. And I wish him and his family all the best. Thank you, sir.
Thank you, sir. I would now request Dr. Achila Danayat to come on the stage and say a few words. Dr. Danayat, please.
Hello, everyone. Thanks to Professor Pillai for giving me this opportunity. And actually, I must say that I'm privileged to be talking about Dr. Shivram. My association, like Professor Anil Kumar said, goes back to 30 years when I was a PhD student at IIT Bombay. And while everybody has talked about Professor Shivram as the polymer guru, I must tell you some, just one or two facets of his personality, which really have appealed to me a lot and have created a big impact on me. So Dr. Shivram, when I was in NCL, I remember there used to be a lot of people waiting in the queue to meet him because he would be traveling a lot. And I was just teaching in an engineering college. But when he would see me in somewhere, he would say, come, let's go and talk. And I would feel so guilty because there used to be people waiting to meet him for a long time, but he still gave me a lot of time. And I think that's one part about his personality, the humility. At that time, he didn't think that I was a very junior person, but he always gave me the time, and it really made my day. And it was as if after I came out of meeting him, it was like an energy dose for me. I would always be very positive. So thank you very much for that, Dr. Shivram. And the second quality, which I really very much admire, is his quality of appreciating people. So every time he hears about me getting a promotion or me getting a new role, he takes the efforts to write down an email to me. And I must admit that he has a really very good flair for writing. And every time I get a mail from you, Dr. Shivram, it really makes my day. So how many of us take the efforts to really appreciate what somebody else is doing? So I think these are two qualities: his humility, his respect for people, and his quality of appreciating everybody and what they do is really, both of these have really made a very deep impact on me, and I try to follow the same principles which I have learned from Dr. Shivram. So Dr. Shivram, thank you very much. Wish you a very happy birthday, and wish you good health and happiness for the next many, many years. Thank you so much.
Thank you, ma'am. I would now call Dr. Anant D. Kulkarni, who is going to represent Department of Polymer Science, to say a few words. Yeah. Dr. Kulkarni.
Thank you, madam. Thank you all. Thanks for giving me this opportunity. So I was just thinking, what should I say? So let me just, wrote some small points, maybe 3 minutes or less than that. Respected dignitaries and friends, it gives me great pleasure to say a few words where we all have gathered for felicitating and expressing our love and gratitude to Dr. Shivram, sir. Well, what can I say about him? My interaction with him is just 1.5 years, and many things have been said by all the eminent dignitaries through today's session. So it's rather a difficult task to say about his multifaceted faceted personality. It's rather a difficult task. But let me put this. Within last 1.5 years, what I had interactions with him, he's not only dean to us, but rather mentor to all of us at Polymer Science Department. So he's also supportive, very kind, supportive, encouraging. And when I expressed my ideas that about developing a course on simulations of polymers, he said, just go ahead, Anant. And with his initiative and support from Honorable Vice Chancellor, sir, we'll be soon developing a computational laboratory for simulations of polymers in our university. And that not only matches but rather resonates with the mission and vision of our university. So that will be something very interdisciplinary. Now, like what I said, I'm unable to find the words which will have proper soul to express my gratitude to him. But so let me use some borrowed guns or other words by William Shakespeare. His life has been so gentle and the elements so mixed in him that nature might stand up and say to the world, yes, this is our man. God bless you, sir. Happy birthday. Even at the cost of being so formal, let me say, thank you, sir. Thank you all. Thank you.
That was perfect rendering by the department and representative of the department. I would now call upon Dr. Nikhil Singha to say a few words. Yes. Dr. Singha?
Yeah, Dr. Shivram and Madam, Professor Jadhav and Professor Ramakrishnan, Professor Pillai and other dignitaries, in the audience. Yeah, in fact, I am the first best student of Dr. Shivram. So I know him since 1988. And I have the privilege to have been with him for my 2 degrees. Master degree, I did my master's thesis with him and PhD thesis. In fact, after my master's, MSc in IIT Kharagpur, myself and Dr. Shivram also knows that Arnab Dasgupta, and we are thinking that we'll be exploring something in new world, like we came to know the polymers are very interesting material. So we came to know that Dr. Shivram has joined from IPCL to NCL Pune. And so we got the ticket and we arrived in NCL Pune. Gracie was there and Fal Sheikh was there, his secretaries. So we could get an appointment with him. I had a lot of questions in my mind. What should I do after MSc? I need also need a family background. I need a job. I got also very good score in GATE. I also scored in CSIR, GRF. Arnab had the same thing, but Arnab, he did not have the GATE score. So he has determined he will go for the PhD. We talked to Dr. Shivram. Arnab decided to join. I was in dilemma. I told that, sir, I need some time. Probably I will continue my MTech. But I would like to do MTech, that thesis, 6 months project thesis you have to do. I want to do with you. I don't know, okay, fine. So that's what I started my journey in. After 1 year, means after finishing my coursework of MTech, and I did my master's and later on continual PhD. And I saw, as Anil rightly mentioned, Polymers 91 is the probably first international conference on polymer science and technology. It was organized by Dr. Shivram and with galaxy of well-known scientists from all over the country, from our India. And also I saw Professor Ramakrishnan. I met him there. So he was supposed to, later on I came to know him, he was supposed to join also in NCL, but somehow, he went to IISc. Later on he was telling the story. So that's what my journey started with Dr. Shivram. And many people told about him, and as Asula just nicely told, very nice human being and very nice appreciating person. One important quality I saw in him, self-confidence and the confidence. If we see the polymer science in India, as rightly Professor Maselkar told today, after Professor Palit, Professor Santappa, somehow polymer science was not growing in our India. And Dr. Maselkar was a visionary scientist. He saw in IPCL that this person, if we hire him to NCL, and then polymer science will see some light. And he was a dignitary, very visionary person, and he hired him. And Dr. Shivaram told, he never applied. He got an invitation to join, NCL Pune. And so, as Dr. Shivaram and Dr. Maselkar told, we can call him as Mr. Polymer. And I call him as Shivaram brand, okay? And like Dr. Shivaram also, I came very late to my home. And thanks to Rama madam, she had a lot of lessons, given a lot of lessons to my wife. She doesn't say anything. She says that, you are Dr. Shivaram's student. Okay? So Shivaram's brand, this is very important in this aim. And thanks to Dr. Ramakrishnan, our SPSI president, we have started also Dr. Shivaram's endowment lecture, like Professor Santappa's award, Palit's award in ISS, and also we have started Dr. Shivaram endowment lecture, and it was well supported by SPSI, especially Dr. Ramakrishnan. We also get a lot of input from him. And on his, I don't say it's 75th birthday, but I say 75th birth anniversary. Okay, and I didn't bring my laptop because my lecture is tomorrow. In fact, 65th birthday, we celebrated in IIT Kharagpur. I was very fortunate to, to organize his 65th birthday in IIT Kharagpur. We were organizing this one international conference in IIT Kharagpur, and probably I'll show some pictures from that tomorrow. And yes, we are also organizing, European Polymer Journal, the special issue on functional polymers. This is, tribute to Dr. Shivaram's 75th birthday, and many scientists also have got invitation, and I think maybe Boje, he is taking a leading part of that. Maybe he can say a few words afterwards, And so we are doing a lot of things on his honor. And thank you very much, sir. And another last person, as last point I would like to make, that on every man's success, there is a woman. Okay. Without, Rama Shivaram, I think Dr. Shivaram would not have been fulfilled. Thanks to Madam, and also being with him, and also being with us when Dr. Shivaram was starting his journey in NCL. We all were working very hard. No lab, no glasswares, nothing. He started. We were developing the lab. We used to work till night, 11 o'clock, 12 o'clock. He used to be there. Sometimes funds are not there. He used to give money from his own pocket. We used to buy the chemicals. We used to buy the glasswares. So this kind of dedicated person, and because of whom, and Indian science is going so far, and it will lead. And as I also wish, like Anil, that we can make the birth centenary celebration for you. Thank you very much.
Thank you, sir. And now we have a student representative from Department of Polymer Science, Ms. Aditi Chaman. So she will say a few words and her experiences with Dr. Shivram.
Good evening, everyone. Thank you for this opportunity. Um, I would like to represent the batch of 2022 of Polymer Science, and we would like to really thank Professor Shivram for putting such a curriculum which would help us to get through this pandemic academic, and which would help us survive in the industry further. He really took an initiative by not only taking insights from the teachers, from the faculty, but he also interacted with the students and made changes in the syllabus accordingly, which is really helping us now. And Sir, over the period of time, he has significantly altered the perspective of looking at polymer science along with all his other fellow scientists. And we are all here to celebrate science with him. And he has been inspiring all us budding scientists throughout these years by his work under his mentorship. Thank you, sir. And I would like to pray to God for your good health. Thank you, sir.
Thank you, Aditi. And now I would invite Dr. Bhoje, who is also his student, to say a few words.
Respected Professor Yadav, Professor Sivaram, Rama Madam, Professor Ramakrishnan, Professor Rasakaran Pillai, and ladies and gentlemen, very good evening to all of you. So, of course, I know Dr. Sivaram for the last 25 years or more. So, I am from a local university, and I did my MSc Tech in Polymer Science and Technology. So, when I have completed that course, so I already mentioned to Professor Ramakrishnan, for me, Professor Sivaram and Professor Ramakrishnan are like the great mentors. So my dream was both of them should know my name, so at least because I did polymer science. So that was my dream. Because I happened to attend their talks, so I got an Professor Sivaram came all over to our place. That's like a kind of a deserted area, Anantapur in Andhra Pradesh. So and he gave a talk. So that has really enlightened many of us, and really I wanted to do research because of only attending a single talk. So then I came to NCL several times, and I met Dr. Sivaram, but I did not get opportunity to speak to him in detail in first 3 meetings. I failed, but later we got, I got a chance to enter into the NCL. Then I got a first opportunity, so as I already said, so Aindavan University people, they visited CSR NCL for a meeting. Around 40 delegates were there. Then Dr. Sivaram, I was not even knowing that he remembers my name. He sent me a chat saying that I have to give a talk in that meeting. Only 3 students, we got an opportunity. So then somehow I was so nervous. Even my PhD supervisor was so nervous. So because I never gave a talk in the public auditorium or something. So then Dr. Sivaram said that nothing doing, so you have to deliver. You have to take this responsibility. Then that was the first talk I have ever delivered in as a student or something. Then later, of course, I got so many opportunities, and Dr. Sivaram has made a significant changes in many rurally backward area students. That's the point I wanted to make. So that is the quality of Dr. Sivaram's inspired many of us, and that is the reason we are all like very much indebted to you, sir, and we really, we are emotionally connected to you so much. So this is the first thing I wanted to mention. The second thing is, just now we have seen some of Dr. Sivaram's students gave talks. For example, Abbas and Suvarna Samrai. So the Suvarna Samrai's talk was so good. Both of them they delivered, and tomorrow we see Nikhil Singha's. So when I had discussed Dr. Sivaram about the student's career, So he always told me that none of my students should join in academics because I want Indian polymer industry has to grow. It means he's like a real visionary. He never wanted his students to be like faculty members or scientists in government organizations because his aim was, or his aim is to develop the Indian polymer industries. So this is the point he told me categorically. Many of his students may not like it because everybody wants to become like another Dr. Shivaram, but he never wanted people to be in academia. Instead of that, they wanted to contribute to the growth of Indian GDP or Indian industries. So this is like a real visionary. And like this, I can say so many things. With this, I will stop here. So I take this opportunity to wish Dr. Shivaram and Madam once again a very, very happy and healthy life. Thank you, sir. Thank you very much. Yeah.
Thank you. Now I would invite Professor Swami from IIT Bombay to say a few words. Yes, Professor Swami.
Thank you very much. So it's a pleasure and an honor to be here. So Dr. Shivaram was my first boss, right? So I came back after I finished my PhD, and I visited NCL in the late, probably 97 or 98. This was before I finished my PhD. And I was amazed at the vision and at the sort of the overall atmosphere at NCL. Right? I was delighted that close to when I was finishing my PhD, I was offered a job there. And subsequently in 2001, I returned and took up my first job at NCL. And this was in the Polymer Science division, where Dr. Shivaram was then the division chair. It was an amazing time. I mean, a large part of that is really thanks to Dr. Shivaram. I think people have spoken a lot about his science and the contribution he's made to science and industry and so on. But for me, I think the thing that was that I most value is the generosity he showed as a mentor, right? So I came back and I had all these ideas, and he was always very encouraging and supportive of all the things that I sought to do. So I had an absolutely amazing time. So the first many years that I was at NCL was, very productive professionally, but also really very fulfilling, in many, many ways. So for that, thank you, Dr. Shivaram. That was an amazing time, and thank you so much for making that happen. So I'll speak tomorrow. I speak in the first session tomorrow, and maybe I'll add to some of the things that I was saying today. So thank you again very much, and thank you for the opportunity to speak here. Thanks.
Thank you, sir. Now I would request Dr. Wadgaonkar, sir, to kindly come on the stage and say a few words.
Good evening to everybody. Of course, thank you, madam, and thank you, Professor Pillai, for giving me this opportunity. What can I say about Dr. Shivaram? He really transformed me because, I was working at NCL even before Dr. Shivaram came to NCL. And, like we were doing some kind of mundane things, let me put it that way, because I came from a state university, did my PhD at NCL, but we didn't know about the world. But Dr. Shivaram showed us the stars. He taught us to stand tall. I think that's what he did, And of course, on another occasion, I mentioned that he is like a head of the family to us, and he built that confidence. I think that's what I value, and I respect him for that. And of course, I will remain all my life indebted to you, sir, for all that what you taught us. Of course, I learned a lot of things by interacting with him, by seeing him, how he conducts himself, how he conducts the meetings, how he, like Dr. Mashakar mentioned today, working with G, that was, I think, the golden moment in my life also, like getting an opportunity to work with
multinational companies, and that's what really transformed, many of us. I think that's what is the greatest contribution of him to Indian polymer science, Indian polymer industry, and also to the world. So thank you very much, sir, for making me what I am today. Thank you very much.
I would now like to invite Ms. Priya Bhumkar from Saujanya Color Private Limited to say a few words.
Good evening, everyone. What an occasion it is. Actually, what does one say about a giant figure like Dr. Shivram, whose impact is so, so large in the space which he inhabits? I have known Dr. Shivram for much fewer years than a lot of the people, legions of people who have spoken before me. I've known him just for about 5 or 7 years on a common industry platform. But the thing which really struck me the most in my interactions with him, and as I witnessed his interactions with others, is really how green is his personality, how green is his mind, which is an absolutely fertile place, which is constantly busy with ideas and innovation. How evergreen is his spirit. It is so lively and so warm, always, and it's always about people. How green is his thought. Sustainability, safety, environment are at the top of his thought, always. And green and evergreen are his relationships, people, and all his relationships with people. And as we have heard so many people speak before me, they're always so fresh, lively, and everlasting. I have been really amazed at the immense scape of his knowledge. It's like this large, green, uninterrupted vista of knowledge, budding with fresh shoots, each of which is striving to go deeper into the ground in a quest of its own, and reaching high up above the ground to touch the skies. Dr. Shivram, on your diamond celebrations, wishing you continued evergreen and ever more armfuls of love, grace, happiness, and good wishes.
That was really flowery, green, and beautiful, ma'am. It inspired all of us.
Yes, so there was a lot of polymer happening. I thought, let's go biology.
Thank you very much. And now it is my pleasant job to thank none other than Madam Rama for being here and making this felicitation program a great success. As we all know, that behind every successful man, there is a woman who stands by to support. So let us give her a very big hand. And what his student said, I would repeat, that without her support, he wouldn't be what he is today and what we have heard about him. And that's the greatness of women. And I'm sure all the women sitting here in this auditorium will agree that women empowerment matters. Thank you very much. Yes, so now I would invite Dr. G.D. Yadavji to please say a few words.
The hero of the day, Dr. Shivram,
should I call you Shivram Anna or Shivram Garu? Yes, now you got it. Mrs. Rama, Professor Ram Krishna, other dignitaries here. You know, I was in Pune today, and Professor Pillai said, you have to attend this function. And I said, I may be late. So he said, it's all right, you join anytime. And here I come. It's like, you know, somebody goes to some function and the princess garlands you, it is like that. And you asked me to chair this session. I'm very happy because Shivram is a very good friend of mine over the years. So, you know, this function reminds me of something. When you retire, that day so many people are happy because they are angling at your chair. But if that function happens after 10 years or 15 years, that shows the love and affection. So that is the difference. And I know this gentleman for a number of years now. And we work on some committees together. We have, you know, a forum called Samvad, where we talk about material sustainability. We write some articles. In fact, we meet every 15 days through video conferencing. But you know, I like something about him. He's totally independent. We have been working on some committees of INSA and others. We have totally independent views on many, many things. And he respects somebody else's views also. And he was on the you know, board of governors of ICT, which is a deemed university. Prior to that, it was an autonomous institute, and he has been associated with us. And we always valued his suggestions, and he would give very nice suggestions. In fact, he's the one suggested to change the name of that department of PPV. J.R. Shah is here. He will always call it as PPV, paints, pigments, and varnishes. He said, what is this PPV? Let us call it Department of Polymer and Surface Engineering. And we changed that name immediately because I was the vice chancellor. I said, okay, let us name change, you know. So you are responsible for naming some nice thing, you know. So it is a legacy for us. It is a legacy. It is a very nice thing. But very importantly, you know, he had many opportunities. He came from IPCL, okay? He rose to be the director. And I knew all the directors since the time of Dr. Alkyd Resins, then Dr. Mashelkar. He went to Delhi, then Paul Ratnaswamy, and then Shivram. You know, he did very well. In fact, when he was to be extended, if I'm not mistaken, he was in United States. He was at Purdue University. And he was extended. And later on, he was asked to be the Director General of CSR, and he refused. So I'm not happy with you about that. He could have definitely changed CSR. He had the capabilities to change CSR, but he had his own reasons of refusing that Director Generalship. Normally, mortals don't refuse certain opportunities. So he has refused. That shows his commitment to science and engineering. And you see, and in polymer science and engineering, there are always monomers. That polymer does not become polymer unless there is a monomer. So all of you are monomers, you becoming polymer today in the honor of Dr. Shivram. That is what I found, that all of you, talked so nicely about him. I know him. We have been friends. We exchange emails. And if I'm not mistaken, he was also responsible for my being vice chancellor. Right? He's not. So because Dr. Mashelkar must have consulted him because he was already a board member. Dr. Shivram, they say in Sanskrit, Jivet Sharada Shatam. That means you should live 100 years. It's not, so they are demanding. And now they are demanding, and not this Somaya, is Samir around here? No, Somaya in university now wants you to serve and make many more entrepreneurs, like Priya said. Priya is a great entrepreneur. I know her very well. So Priya, your wish will come true, very definitely, because Dr. Shivram and Madam Shivram, and how do I know Madam Shivram? He introduced me just now, but he doesn't know that R. Krishna always talks about her than you. You know R. Krishna, right? The professor in University of Amsterdam. Whenever he meets me, he will tell me our stories about you and then Shivram. Right from your IIT Kanpur days, you know. So all those things, so it is coming like a flash to my mind. And so I'm indeed honored to be asked to chair this felicitation function in front of so many giants. So Professor, Pillai, Rajshekaran Pillai, I was here in March for some function. And he told me that you have to come here on this particular day. And I said, yes, I will definitely come. So Professor Pillai, thank you so much. And you have got this great man. So you have to ensure that you keep in him good humor so that he will be very productive. And I'm very happy to see Mr. J.R. Shah, he's doyen of polymer industry, our ICT alumnus, and many others like Satyen Gala and all others who are here. I am very happy that they are here, Wadgaonkar, and I don't know whether N.N. Chaman was also your student. He was your student? Yeah. So all these people respect you a lot. And so I would certainly hope that you continue working because, there is nothing like a retirement age. I can tell you that. You have to keep working. If you think that you are retired, your wife is going to make you work at home. So don't say you are retired, okay? Otherwise, you have to do all this jhadu pota. Yeah, so you should always work. And to keep young, you must work. And I think I have become, busier than before. I don't have any administration, but I don't find any time. I've been doing everyday things, going here and there. I don't think I'm retired. I'm much younger now, but that's what I feel. So, Dr. Shivram, I wish you all the best, and I request you to continue working, and we'll work on that samvad. Let us take it to the next height, because we are working on something called materials and sustainability. We are not just talking about polymers. We are talking about everything under the sun, and you will see that in our website. So thank you so much, Professor Rajshekaran Pillai, for inviting me. I really enjoyed, and I like the way in which his students have talked about him. That is the way a teacher should be. A teacher is supposed to inspire. A teacher must tell the student he should have patience, because results don't come overnight. You have to work like mad. And failure is temporary. Success is autocatalytic. Once you are successful, like your first paper is accepted, then the student knows no joy, I tell you. That is the greatest joy in the life of a student, when his first paper is accepted for publication. He goes on giving tea parties to his students, friends and whatnot. Second is perseverance. You must have perseverance, otherwise you cannot become successful. And you ask anybody who has become successful, he has perceived. And the last P, these are 3 P's of success, is the P is patience. You must have immense patience. And then pardon. That P has to be converted into pardon. If you don't pardon people, because there are so many people whom you help, they may go against you also. Sometimes it happens in life. But pardon them, because if you pardon, that person thinks, why he has pardoned me, he becomes restless. You can sleep very nicely. If you pardon people, you can sleep nicely. The person who has troubled you and you pardon, that person is rested. And since you are in academic, in this polymer science department, another 3 P's I'm going to tell you, that is patent, publish, and prosper. This is the 3 P's. So you must patent. Many of you have patented, but also then publish that result, and then you will become prosperous. With these few words, once again, I congratulate Professor Shivram on his Diamond Jubilee of the birthday, right? Diamond Jubilee. Let it be 100 years celebration. That time we should all gather here to celebrate his 100 years. Thank you very much.
Thank you, sir. That was really very exciting, and not only exciting, very humorous. And now I would request Professor Ramakrishnan to say a few words.
what can I say of such an entertaining best wishes for Shivaram. I didn't get a chance, I'll be very brief, but you know, I met Shivaram first time when he was in IPCL. I'm not sure he remembers, but I was a PhD student, and I had a very good friend who had joined IPCL by name Chandrasekhar. Vadapalli Chandrasekhar was my housemate when I was doing a PhD in the US, and so I forced myself, I think, in IPCL. I just said, look, I'm coming back, I'll be going via Bombay, I want to see you. A close friend of mine, and he said, yeah, come, I think Shivaram is here, and why don't you give a talk as a PhD student? And I actually went there and gave a talk at IPCL that I had not finished my PhD. I was just doing my PhD, and that's the first time I met Shivaram, and Vadapalli Chandra has told me so much about him. So it was a real pleasure for me. I recall the meeting with Shivaram. I'm not sure he does, but it was something. IPCL was a place that was waiting to happen. I could sense that, but from what I've heard from so many other people, I probably did not realize what really was happening there. So I just got a superficial sense, but now I really realized that there was a real important period for IPCL where they were pushing science and trying to develop technology, from what I heard from Gupta as well. So subsequently, I heard that he had moved to NCL, and I was looking to come back to India. My objective was to get back to India, and I was applying to many places, and NCL was also one of them. And Shivaram actually made me an offer. And academic institutions was not getting back to me, and I was, and since Chandra had told me so much about IISc, I had not visited IISc before that. So he had told me that, look, IISc is a fantastic place, and you know, you should, if you get there, don't go anywhere else. That's the place to go. And so Shivaram made me an offer, and I was trying to figure out how to hold back the offer, you know, so that, because I didn't know whether I will get in IISc at that time. So I was trying to, he will send it by speed post, and I will write a small letter and send it by regular mail. So he would, he didn't know the trick, but it would take me 2 weeks to go those days, and it would get there, and then I will ask some questions. I had many questions, but one by one I will write it. Send one mail, and then it would come. Response will again come by speed post. And then I would hold on, what about accommodation? You know, then he will again send this. So at some point, I was very lucky to get this offer from IISc, and so I had to politely reject or refuse to go to NCL. I think if I had joined NCL, I would have been just as happy and productive and enjoyed my career as I have now, when I hear so much about the enthusiasm and happening place in NCL. And I actually, later on, I visited NCL. When I decided to join, I wrote to Shivaram and I said, I'm going to IISc, but I'd like to visit NCL. And he immediately accepted, and I went and gave a talk there. And then I got to know about him a lot more over the last several decades of interaction. He's been an incredible mentor, somebody whom everybody would try to emulate in so many ways. I mean, so many aspects of his character has been reflected upon by so many people. I completely concur with all of those. And you know, as many of us have felt, you know, there are certain aspects of personalities of people that you take away without knowing, really. You just watch and you learn and you emulate. And he was one person like that. And his love for polymer science and for activity in polymer science in the country and to promote polymer science in the country is incredible, as it was evident from the way he championed the Society of Polymer Science for more than a decade. And so he has a very soft manner, by which he would indicate that, you're not doing well enough. And I must concur that as a Society of the President of the Society of Polymer Science, I have done very little compared to what the stalwarts like Shivram, Mashelkar, Ashok Mishra, I.K. Verma have done. I have basically just gone along with what I've done, and I've continued to be inspired and also gain a lot of advice and on how to move the society. So I think from all of us who are members of the Society of Polymer Science, on their behalf, Shivram, I'd like to say that we've been rewarded by your presence in the society and by your guidance. And to say I've been very fortunate to travel with Shivram on many occasions, especially because of the Federation of Polymer Asian Polymer Societies Association, and as a result, I've gotten to know Rama a lot better as well. And it's been always a pleasure, Rama, to interact with you, to enjoy conversations with you, and both of you have been just a wonderful companion in all our trips abroad. So with that, I'd like to wish you, Shivram, for as many of them have said, I think as he aptly said, when we say that we want to celebrate 100 years of your birth, we are also saying we want to live another 25 years. So I think that is a really innate part of this desire. So I really hope we'll all be able to be here for your 100th year celebration. So thank you all very much, and this has been a real pleasure for me to be here. Thank you.
Thank you, sir. And now I would request.
Can I say something?
Yeah.
I forgot to say this, because I'm a professor, I should say this. Dr. Shivram is not Shivram today, he's Shiva Rama. Shiva and Rama.
So I will now request Ramaji to come and say a few words. Yes. So please.
Good evening. Thank you for asking me to say a few words about Shivram. Well, everybody has spoken about him professionally so well. I would like to say a few words on the personal front. I met him in '74, and we are opposites. North and south, east, west, North Pole, South Pole. We just don't see eye to eye. And maybe that's why opposites attract. And when my mother told me I must get married, not to him, to somebody else, I just casually spoke to him. I had met him in IPCL Baroda, and there were a lot of pretty women around him from my hostel. I was the one with the buck teeth. I was the chubby one with just 2 pairs of jeans and a buttonless kurta, and he gave me a pin one day. He said, you can wear a pin on your shirt. So that was the kind of man. And when he said, you're not ready for any relationship, marriage, anything, you're too young, go and study further. So I joined my master's, and then he said, after my master's, maybe you're ready to get married, I shall marry you. And I said, I told my mom, she said, what kind of a guy is he? I said, he's a born Confucius. I said, for my hyperactivity and emotions, he would be an ideal balanced person because he just does not react. He is like the Mauritian dodo, which is a bird, extinct bird today. So we married, and we learned romance, and then the students came in the way in Pune. Neither did I have money, and it was all being given away to poor students of his. and neither did I have his time with me. So I thought that who would be the correspondent when I file a divorce against my husband? There would be 40 students whom I would have to, list out. But eventually it worked out. There are a lot of highs and lows. And well, as I said, that I'm extremely emotional. And let me tell you, the way he has worked for the students, he has never worked for me that way. Not one paper of mine has he reviewed, because it's not a peer review. He says, I don't know your field, so why should I? I said, but say a few words. I need some positive stroking. He says, no, that should be done by others, not by me. So that was the kind of person with whom I am. And many times we never play with words. We are very honest with each other. So you may call him Dr. Shivram, but when I'm frustrated, I call him either a dodo or I call him a Satyavan, because the honesty goes to such a level that it can be very frustrating for a person. So that is the kind of person. And well, we have gone on this journey, and it has been, we are very good friends. Every relationship transits from one phase to another phase. And we are very good friends. And I would like to say just a very apt word by one of my artist friends, who was the dean in Delhi, Jamia Millia, and other places. He said, Rama, you and Shivaram are like the first string and the last string of a tanpura. I go screech, and he goes, that is how we are. But eventually, it is the tanpura, and I think we have made good music. So thank you.
So this was a perfect blend of art and science, and that's what makes them most compatible couple. So once again, a heartiest congratulations to both of you, and we now close this session, and we will have dinner, which is...
Why are you not asking him to speak?
Okay. Okay, I'm sorry.
Dinner can wait. Are you hungry?
No, sir.
No, I have spoken enough today. I have spoken enough. No, I don't respond to her at all. So it's quite dangerous to respond.
And that too in public.
So thank you so much. Honestly speaking, I see so many great friends of mine here, my past students, my professional associates, my colleagues, and many, many people whom I have seen here today. I mean, it's not easy for everybody to make time. I see Mukesh Bhutta there. Thank you, Mukesh, for coming here, for having, I saw Priya. I met so many people in my life. It's been a wonderful journey in my life. It's been exactly 50 years since I started my professional life, and this professional life of chemistry has given me everything, honestly speaking. The great people whom I have known, great students, very committed students, who bore with all the torture that we gave them, and then even then after so many years they're coming and telling all the good things about me, but I know I have made them cry very often, and I think it's such a pleasurable occasion. Thank you, Professor Pillai, for this occasion. I didn't want this because I don't like to get emotional, but I don't like to say things that I'm not prepared to say because I have not written my speech as yet. But it is indeed a most happy moment for me. And I'm happy to see all my friends, people who are senior to me, people who are younger to me, today gathered here. If all of this has happened, I only say it's my good fortune. I didn't do anything special. I was what I am. I continue to be what I am. I speak my mind. I speak the truth. I'm honest. And I don't say anything to please anybody, but I say things because it's the right thing to say. And I think that has helped me because people have seen me as a person whom they can depend on. And as I said in the morning, this is a kind of a relationship which is born out of great amount of trust and faith, you know. And I think Rama talked about our relationship. You know, a husband and wife relationship is also a very turbulent relationship, you know, because although you may not admit it publicly, but I think because they are two different people, you know, there are two different individuals who come together, and the more they're independent, you know, the more turbulent the relationship is. The turbulent doesn't mean that the ship will wreck. It only means that you need to be steady, okay? And I think that only thing that builds that relationship is, I think everything is forgiven as long as trust and faith are there, you know. I mean, we all make mistakes, we all err on sometimes, but the trust and faith is what keeps us going. And that's true with also the professional relationship. It's a personal relationship, it's a professional relationship. Yes, Rama has been my fiercest critic, you know. In fact, I shudder to face her after anything because she will give me the most, you know, critical comment on everything, you know. But I appreciate that because I think we all need to have a mirror sometimes because none of us are perfect, you know. And I think it's nice if somebody tells you that you are imperfect. And as long as that somebody who tells you has no ill feeling for you and it's based on, let's say, true affection, I think that criticism we take very seriously, you know. Otherwise, any criticism we tend to kind of, you know, go on the self-defense and argue that we are right. But if a wife criticizes her husband, I think the husband is better listen. And I think she has been one of my fiercest critic, you know, and in the right way, you know. I think the criticism is very worthy, and it's something that I need to learn. And I think that's how we improve ourselves, you know. And so thank you. I should not be talking here for long. Thank you, Yadav. You came all the way from Pune straight here. You know, as you said, you know, Yadav, I mean, apart from the fact that Yadav and I have known each other for several years, you know, these two, I always say NCL and ICT have the same DNA, you know. And somehow I feel part of ICT, and I'm sure he feels a part of NCL, you know. And these are two rare institutions in this country which share that institutional DNA, you know. I mean, and that's because a lot of people from ICT have moved to NCL, and a lot of people, you know, and that kind of a bonhomie, that kind of a relationship that exists. And this is a very, very rare relationship, you know, between two institutions like NCL and ICT. And that's because we share DNA, you know. And so that's apart from the relationship that I and Yadav share as two individuals. But I think he has been a great person. I get inspired from his energy is phenomenal, you know. I mean, you just read his biodata, you know, and I can't believe that he can do so many things and get accomplished. I get tired sometimes, you know, and I said, forget about it, you know, let it, you know, let it lie wherever it is. I'm not going to bother about it. But I don't think he's like that. I think we would celebrate your 75th birthday, okay? So it's not going to be very far, another few years, and we will definitely celebrate your 75th birthday, but I think he's going great guns. And thank you for coming here. And Ramakrishnan, you know, it's not so important what you do as a polymer science president, but I think it's the presence of you which makes a difference, you know, because people like to see role models. And I think every successive generation must see the role models. The role models are not what I call once in a while, but I think every generation must have several role models. You have created many of them today. I think that's your legacy as a person who was devoted to the science. And I think we have all created this new leadership, which hopefully will give us the inspiration for the next group of young people to do what is right, to do well, to excel, and to bring honor and fame to this country. I think that's the end goal for everything that we do, is basically because we are born here, we are destined to live here, we need to make this country great. And I think that's the only spirit in which we all provide our service. Thank you. Thank you, Padma. You have been an excellent host and compeer, and thank you for this occasion.
Thank you, sir. Thank you. We now close today's session, and we'll meet tomorrow morning. The dinner will be served at Gargi Plaza, and tomorrow's session begins at 9:30 a.m.